Okay. Can you hear me well? Great, thank you. Okay. Thank you so much for coming. I'm super excited to be here, also in this conference specifically, which is really awesome so far, but also in Austin, Texas. It's my first time, and so far I'm loving it. Is anyone here from Austin, Texas? Nice. Fell in love with it like 3 days ago when I got here, and I went to Terry's Black to eat a barbecue. Like, whoa, what is this? I tried to go next day, the following morning, but it's not open at 8 o'clock in the morning, so I went 2 days in a row afterwards. But I'm not here to talk about barbecue. I'm here to talk about events, specifically events in distributed system, ensuring transactionality of events, consistency of events, meaning if something happened in the system, was an event actually published? My name is Matan. I work as a software architect at a company named Melio. Maybe some of you may have heard. I'm very fortunate to work at Melio, to have been working at Melio for about 4 years now. So I've seen us grow from processing just a few $1 billion a month to a few $1 million a month to billions. It's still, we're not JPM, the talk before, but still, it's high scale to see. And as the scale goes up, the issue of consistency of events, it hurts more. For example, when we were small, if once in a while an event is not published, that's fine. But once the scale goes up, suddenly the numbers go up, and it's not something we can actually handle manually anymore. And another thing that affects how painful it is, the consistency of events in the system, is the domain. So for example, I think that from my experience, in a domain, let's say a social network, it could be less painful if events would not be sent every once in a while. I'll give you an example. Let's say we're working on a social network, and we have this number of likes per user. And every once in a while, some events do not get published, and the effect is that a user would see, instead of 160 likes, he would see 159. Is this a good user experience? No, definitely not. Users should be able to see the exact amount of likes. But if we will compare this to the fintech domain, the same problem, that every once in a while an event is not getting published, would mean for some users that schedule the payment to a vendor at the end of the month, the payment would be delayed or maybe not sent at all. In which of these cases it's more painful and more chances of the user complaining? Probably fintech. This is the reason I love fintech, by the way. And the domain is not the only thing that affects how painful it is that events, the consistency of events, also your architecture. So if you are working on a distributed microservice architecture that is event-based, how many from here are working on a system that is microservice event-based? Okay. By the way, the ones who are not, interesting, what are you doing here? No, I'm joking. But what is the alternative to events? What are you doing? How are you communicating between services?
I have events, but not in microservices.
Okay, got it, cool. So what happens in a microservice architecture that's event-based, and you see I've done here this beautiful animation, if services communicate with events, I would argue that these events, they actually mean small pieces of state of the whole state of the application that's passed between services. I'll give you an example. Let's say we have a payment service. And this is the only service that clients can create payments from. So when a client creates a payment, this service would create the payment in the database and publish to all downstream consumers, payment was created. One of these downstream consumers could be risk, could be analytics, data. Let's say the risk team did not receive an event payment created. There is a high possibility of that team saving that event in the local state database. So it means if they don't get this event, they're out of sync. And this is very painful, okay? Which architecture this could be less painful? Again, it's not that the problem does not exist, it's just less painful. If you're working on a monolithic application, say what you will about monolithic applications, like one service, one database. If an event does not get published, maybe a business process does not start, yes. But the next time you fetch all the latest information from the database, you have only one state. So it's up to date. Another example would be if you have multiple services in one database. Not that I recommend this pattern, but every pattern has its trade-offs. OK, so I'm talking about why it's painful that events do not get published. But the real question is, why is it even a problem? I mean, from a developer perspective, all I need to do is I need to do my read-to-write event bus.publish, and I publish an event. So what's the problem? So let's see a simple example and break it down and see if it's actually that simple. So going back to the example of a payment service, we are in a fintech conference after all. So we have this payment service. And when it's being called to create a payment, it has to do, by minimum, it probably does much more. It has to write to the database the new payment, publish an event, and then return 200 to the user. There's a hanging user waiting for a response. When trying to do this, we could arrive here. There could be a chance that we did not manage to publish the event to the event bus. We receive an error. Can anyone here think about reasons why we would end up in this case? Anyone? OK. Maybe we deployed a fault in the code. Maybe we're trying to publish a structure that the event bus does not know how to consume. Maybe the event bus is down. It's a service. Or maybe we received a network issue. I'm not aware of any system without network problems. They always exist, from what I know. If not, please correct me if I'm wrong. So if we will reach this situation. Considering we can all agree that this situation will arrive, what do? Can anyone think about what can we do, considering we already arrived in this situation? What are our options? Retry, great. Great. Retries are great. It's a great idea. The only problem with retry is it's another action, and it could also fail. And we have a hanging user waiting for a response. Maybe we should just roll back. Let's roll back. Let's return an error to the user. Let's say we didn't manage to do whatever you requested us to do, and we're OK, right? A rollback, same as retry, is another action. It could also fail. OK. Thinking about these kind of problems, for me as a developer, sometimes it's just easier to see the code. So let's look at the code. Normally, we would have something like this. Of course, it's oversimplified. So we will have a create payment function. We try to write to the database, and we try to publish the event. And we receive an error from this line. Now, This is an example I love because it looks genius at a first glance. What are we doing here? We know that databases have transactions, so why not open a database transaction and publish an event from that transaction? It's amazing because if we do not manage to publish the event, there's no commit. So it's great. But is it actually that great? Can anyone here spot what is the problem with this pattern?
You managed to publish the event to the event bus and then the database transaction.
Yes. Amazing. Nice. Yes. OK, strong people. So the commit only happens at the end. So we could end up publishing to the world something that we didn't manage to commit. So we published something that's invalid. This is not better than what we had before. So writing to two systems is very hard. It's very hard. It's so hard, it even has a name. The name is the dual write problem. And it can happen from several reasons that we discussed before. Maybe services down, maybe network issue, maybe fault in the code. And like a lot of hard problems with a name, it also has a lot of ways to solve it. And I'm sure most of you heard about these patterns. Great patterns, very good patterns. Event sourcing, two-phase commit, Saga. But the pattern that I wanted to discuss today, I love this pattern because it's simple. And I love simple things because simple things are easier to reason and easier to explain. And the most importantly, it's easier to integrate into a running system. This pattern name is the Outbox pattern. And I'm going to cover exactly how it works. So this is a high level of the same case that we've seen before. We have the same payment service here on the left. But we added something to our system. We added something to our database. We created a new Outbox table. Outbox meaning everything that we want to get out. And now, when a payment request comes in, we write also to the Outbox table and also to the table of the payment. And why this is magic? This is magic because the database, if we are using a database with atomic transactions, it guarantees that rather these two writes success or failed. And we can return to the user the correct result. And we have everything stored in the system. Amazing. But we didn't actually publish anything yet. So here on the right side, this is the magic of publishing. So we actually are splitting here the process of writing to the database and publishing events. So we have here a message relay. His whole purpose is fetching everything from the Outbox table and publish it on the message broker. Now you could say, Matan, what did we actually do here? Because we could still fail. Absolutely, we could still fail. But this is an offline process. We can retry until this event is out. If something is wrong, we can fix it. We have everything stored, and we have what's called event consistency. We can guarantee to our downstream consumers that everything that's written, everything that's happened, 100% consistency is published. Okay? I'll emphasize really shortly about the message relay implementation. Essentially, we want to fetch everything we write to the Outbox table. So if you are using a database like a Dynamo or Mongo that has streams, super easy. You can just hook the stream to a queue and read messages one after the other and process them. If you're using a SQL database, maybe Postgres or MySQL, you have what's called a WAL or a binlog. These databases, they output log files with everything that's written to the database, you can take this log file and create a stream format. There's tools such as the Debezium that help with this process, okay? So we implemented this pattern, and of course it solved our original problem. Our very hard problem, it solved it. But the beauty of this was it actually gave us much more than we originally thought. We came to solve one thing, but we actually changed our system a bit. We are doing two very different things in our system because of this pattern. One, we are writing to the database in one context. In another one, we're publishing event. We split between them. Another thing that changed is we are writing all the history of everything that happened directly to the database. And this is very powerful. Let's see an implementation example of why this is so powerful. So this is an example implementation of how to implement the Outbox pattern. Let's call it the right way, because it's easier when we have right and wrong. So we have here an Outbox table. Of course, it has an ID. We have an index. This is a running number of all events that we have in the system. It's very nice to have this number just to know how many events we have, but also we will use this field a bit later. Remember this field. We have aggregate type. In this case, our aggregate would be a payment, but it could be a user, a customer, whatever the aggregate is in the specific context. Aggregate ID, payment ID. Event type, payment created, payment updated, payment deleted. In the payload, everything you want to publish on the event. Once we implement this and we look in the database looks a bit like, we are at the fintech conference after all, it looks like a ledger, right? It looks like a ledger. We have here a beautiful log of everything that happened to our entity at which point in time. And the most important thing, the why, the reasoning. It's tied to an event. So we can see here the payment was created on a specific date, and it was created for a future date. It was created a scheduled payment. We can see here the parameters. We can see the user updated it before it started processing. So the next time a user complains about why something was processed the way it is, we have all the history. And we can see when the payment started being processed and when it was completed. Every time, which parameters were changed. Very powerful. So we said two things changed. One, we split the process of writing and publishing. The other, we write everything to the database. Let's see, first of all, why splitting the processes is powerful. If before, we used to write to two systems, sorry. Now we write to one, sorry. Why this is good? First of all, if it's implemented correctly, it takes a bit of overhead, but also better latency. We are writing to one system. Great, quick win. What else? Because we are processing events at an offline process, we can control these events. One thing we can do, we could say, from now on, all our events that we publish to the outside world are published by order. We could say, if we fail on a specific event, we will wait until it's published and then move on. And remember the index from before? We will use this index to publish the events by order. You may say, Matan, what did we do here? It would be the same before. We would also publish events by order. But it's not true, because if you think about it, when you are processing in different threads, and while writing to the database, publishing events, and you take into account delays and failures, there's no guarantee that what happened is actually the same order of events that went out. And it can impact a lot the downstream consumers, especially if they're using this state. So this is very powerful. Another thing we could do is, did anyone here experience a case of which, normally happens with batch processing, downstream consumers have a rate limiting on how many events they could process? Happen to anyone? Now we can control the back pressure. We could say, we publish only X events every second, every minute. Very powerful. We could not do this before. Going back, we said also writing to the database the whole history is very powerful. Let's see reasoning for why that is very powerful. How can we use it? And again, when we implemented this pattern at first, we didn't understand how powerful it actually is. OK. So I'll share an example of an actual use case. So at Melio, we process payments. And users can actually update these payments and retry them in case of failure. In payments, I'll not go too much into detail, don't worry, just to understand the case. Payments have two sides. They have two payment methods. Which payment method you want to collect with, and which payment method you want to deliver with. So essentially, you could pay like with credit card, and the vendor would receive a check or an ACH. Okay, we break down these two sides. So when you retry a payment, you're not creating a new one. You are retrying the same payment. A same payment can have like multiple transactions, okay? Now, product comes in one day, says, you know, I've looked at the numbers. Users are retrying like 10, 15 times. Same payment method. Doesn't make any sense. First of all, it's frustrating for them because it won't work after 3 times. Also, it costs money. Can we please limit the number of retries to the same payment method for 3? And if it happens more than 3, let's show a banner pop up and say, you can contact support here. You reach the maximum number of retries. Great. Running to implement something like this, I would think it's legit to just add a new column saying retry count with which payment method, updating it on each retry until it reaches 3, which is great. But it works only from this point on. Users that already retried 15 times would have another 3 times. And this is true for any feature you can think about. If you're working in an e-commerce and you suddenly want to track which orders were in the were in your basket and then removed, the history is all there, straight in the functional database. This is very powerful. We can base new features on historical events. Another example of how powerful it is to save events to the database. Remember the previous example with the microservices? What happens if you're working on a microservice environment, events-based, and a service is down? The service is down so badly, it missed events. Did anyone here experience such a disaster? OK, strong people. So when the service is back up, he's out of sync. What do? It's a very hard problem. I mean, we could solve it in scripting, of course, but now we don't need to. We can move the cursor back, replay events, service is back in sync. Magic. But notice, when we replay events, this is not the only service who will receive events more than once. This means, very important, all downstream consumers must be idempotent. They must be aware that events are going to get published more than once and not to process them more than once. Last example. So, again, example for Melio. We have an internal risk tool, risk group. And they, very smart people, they decide which user can create which payment for which amount. They have these very, very smart algorithms that do this. And every once in a while, they tweak them. But when they do, we cannot deploy them straight to production because it has a massive impact. And also, we cannot really test them against the latest state. Why? Because these algorithms, they care about events in time and not just the latest state of the database, the thing we normally have. So one implementation for this would be deploy a service in what's called a shadow mode, run it a week or two, get results, decide if it's good, no, then deploy the algorithm that we are happy with. But now we have all the events tracked in our local database. And if the whole system is working this way, we could cut down weeks of just waiting. Amazing. Okay. Well, this jumped. Sorry. Not thank you yet. This is a real summary. Oh, okay. Nearly there. Okay, summary. So we started off, we wanted to solve event consistency. This is the original problem we were trying to solve. Very hard problem to solve. We managed to solve 100%. We found out that it actually helps us by having extraordinary debugging capabilities because we have this beautiful audit log of everything that happened to every entity. Our latency improves. We can control ordering of events and back pressure because they're processed in their own offline area. We can base new business logic based on historical events. And we can replay events and use this point in time. Before we go and implement the Outbox pattern, 4 things I thought are very important to mention here. First, we talked about it briefly before. If normally we are in an environment of maximum once, events are normally published. In special cases, they're not. Now we are in at least once environment, meaning events will always arrive, but sometimes more than once. And we have to know to not process them more than once. Be idempotent. Number 2, this is something I cannot emphasize enough. It's so easy sometimes. I hear developers saying, I don't want to talk to my downstream consumers all the time. Whenever they request new information, I will just send everything. So if we're using like Node.js TypeScript, just like JSON Strigify, send it all. Sounds magic, why not? Don't need to talk to anyone afterwards. But it's terrible. It's terrible because it's the same as we were to come to our downstream consumer, say, hey, this is our database, just access it directly. And why this is painful? Because the next time we would like to want to do a migration or a rename, we would break all the downstream consumers. So events are like, we should treat it like a REST API. Even use the same contract, why not? Number 3, meaningful event names. We've seen before this beautiful history of logs of events that happen to a specific entity. The event naming, if it's a business event, it's very impactful. because everyone can understand it. Everyone should understand it. Products should understand the naming. If we have events called S3 file dispatched, the developers that worked on that feature can probably know what it means also just for a few months. Then they will need to dig back and see what it actually means. Good business names are payment created, payment cleared, payment authorized. Everyone can understand it. If we have such names, we could stream all the business events from all the databases in the system to one location, and we have all the user journey through the system. We can do very powerful things with it. Number 4, if I wouldn't put it here, it would come up in the QA. Yes, we're writing all events to the database. Yes, we could have a lot of events. If you are processing billions and you care about storage, the database does not scale horizontally, or you care about pricing every once in a while, probably move events to a different storage. Yes. Thank you very much. Thank you so much for coming and listening to this lecture. I really hope that you rather all learned something completely new, a new pattern, a new tool that you can use, or maybe you learned more about a tool you already know, and now you can use these new things that you know about. Thank you so much for the organizing of this event. I'm enjoying myself so much until now. I hope you are too. And I'm here for questions. Thank you. Questions? Yes.
How do you address scale with your Outbox message relay?
How do you address scale with Outbox? Okay, can you elaborate a bit about the pain?
It feels like that then becomes a bottleneck for all your
The rights?
The rights to the event bus.
The rights to the event bus. Yeah. Okay, so the bottleneck becomes the right to the event bus. Absolutely. I mean, if you decide not to use streams and to just spin up a cron job that runs like multiple times a second and fetch everything, definitely could become a bottleneck if you have a high scale. But if you use streams, it should be much faster from our experience. Also, it really depends on if you care about ordering of events. Let's say you don't care about ordering events, you can just process this in parallel, no problem. You could also say, I want to process in parallel because of scale, but send on the event the number of the event, the index, and then say to downstream consumers, you have an ordering. Even you could receive not by order, but you have to do the ordering. Like, there's different ways to, yeah. Does this answer your question? Thanks. Okay, thank you very much. In any case, I'm here for questions. Thank you.